Just let me know whether you guys can hear this.
Now we can investigate reactivity of metals with.
Did you hear it?
So I didn't hear it from the
Yes, sir.
So I'm putting that from the microphone. I'm not sharing the sounds. Because
then
if I share the sounds, then what will happen? The echoing happens. That's why.
Okay.
Because of two. Okay. So if you want, I'll make the sounds little like louder. Yeah, I'm sharing the screen. Oh, Nick, but I'm sharing the screen. Okay. Right. So this is about the reaction of metals with the acid. Right. In this case, you will be writing some experimental details also. Right. You may be using the last page space in order to write this. Okay. Or even different paper and then attach to this tutorial as well. Okay. Let's move on.
Now we're going to investigate reactivity of metals with acid. The acid that I'm using today is hydrochloric acid. When it reacts with the metals that I have chosen, heat will be given out as it's an exo.
So they are going to react the following metals with HCl acid. And what are they going to focus on? Let's see. Right. Anyway, what sort of reactions are metals and acid reactions? What do you mean? You can see on the board. Exothermic. What do you mean exothermic? The energy is produced. Energy is produced means it's going to heat up everything. You get it? Right? Okay.
Thermic reaction. Remember, you will need to wear eye protection for this experiment. I'm going to do the reaction in an insulated cup. Try and reduce heat loss. The insulated cup is not very stable on its own, so I'm going to place it inside a beaker to reduce any spillages. During the reaction, the temperature will rise, and I will record this on the thermometer. The first method I'm going to use is zinc powder. I'm going to start by measuring out 20 centimeters cubed of hydrochloric acid into the measuring cylinder.
Please understand, in your paper 2, as well as in ordered practical paper, they are very particular of giving those long questions. I mean, long answer questions. Right? Maybe 5 marks, 6 marks. Right? Now they are expecting students to design experiments. So one of the objective of showing this video and without giving the notes, I want you to record this as an experiment after listening to this. Right? For example, you are going to find out how much exothermic is this reaction. Procedure, right? She explained, right? She's going to use an insulating cup placed in a beaker and measuring 20 cm cube of HCl. You have to write. After listening, I'll play this 2 or 3 times. And you have to write the procedure by your own. You get it? Online students, do you get it? Yes or no? Respond in the chat.
Yes.
All right. Okay.
Yes, sir.
So let's go back. So don't be just spectators. You can quickly jot down things and write when you hear because you are going to write it a lot.
Now we're going to investigate the reactivity of metals with acid. The acid that I'm using today is hydrochloric acid. When it reacts with the metals that I have chosen, heat will be given out as it's an exothermic reaction. Remember, you will need to wear eye protection for this experiment. I'm going to do the reaction in an insulated cup. Try and reduce heat loss. The insulated cup is not very stable on its own, so I'm going to place it inside a beaker to reduce any spillages. During the reaction, the temperature will rise, and I will record this on the thermometer. The first method I'm going to use is zinc powder. I'm going to start by measuring out 20 centimeters cubed of hydrochloric acid into the measuring cylinder. which I will now pour into the insulated cup. As I'm measuring temperature change, I must record the temperature at the start of the reaction, 19.5 degrees Celsius. Here I have a lid with a hole in it, so the thermometer will go through the lid. Now I'm going to add 2 spatulas of zinc powder to the acid in the cup. It will take a few minutes for the maximum temperature to be reached, so now I will wait. I'm now ready to do the next metal. The chemicals that we're using today are harmful, so please don't pour them down the sink. Your teacher will provide you with a container where you can dispose the residues for safe disposal later on. You can reuse this cup for the next metal by rinsing out the previous metal with water. What do I need to do to keep this a fair test so I can compare all the metal reactions? I'm going to use the same apparatus and the same quantities of metal and acid in each.
This will be quite useful when you are recording it, so then you can use a pencil and write this down. I want you to write this procedure during the class today, right? You have to write, okay, how to do this experiment. And then I'll show you the data table that they are going to.
Temperature with the HCl first and then add C2 and measure.
Yes, because you want to know what's the initial temperatures before you find the final temperature.
You see what it's close.
No, you can't actually see. You have to depend on what's the information that they are going to give you, right? Yeah, I'm not figure that everything. Okay, shall we continue?
Of the reactions. Don't forget to take starting temperature at the beginning of each reaction.
So here we have the observation table. Yeah. But you need to write the procedure. Then come and make that a copy karagana. But I want you to write this as a proper experiment. Procedure, observation, conclusion. Hold on, table again. Mental notes, figure out. Saki, you are supposed to write down these observations, and then depending on that, you are going to make the conclusions. Anyway, I'll be playing the video again for you to write the procedure. Right? What is meant by procedure? How to do the experiment in point form. All right. So you're basically, you are adding a certain volume of acid into, a metal into a certain volume of acid. And you let the reaction to happen, and you are measuring the temperature change. Greater the temperature change, you can say more exothermic the reaction, so that the metal is very, more reactive than the other. That's our plan. You get it? Okay, so let me play it again from the beginning and write the procedure, write the observation and the conclusions. So why do we do this activity? Because in the exam now they are asking you to write experiments and do all these things, unlike in the previous examinations.
How can we investigate the reactivity of metals with acid? The acid that I'm using today is hydrochloric acid. When it reacts with the metals that I have chosen, heat will be given out as it's an exothermic reaction. Remember, you will need to wear eye protection for this experiment. I'm going to do the reaction in an insulated cup. Try and reduce heat loss. The insulated cup is not very stable on its own, so I'm going to place it inside a beaker to reduce any spillages. During the reaction, the temperature will rise, and I will record this on the thermometer. The first method I'm going to use is zinc powder. I'm going to start by measuring out 20 centimeters cubed of hydrochloric acid into the measuring cylinder. I will now pour into the insulated cup. As I'm measuring temperature change, I must record the temperature at the start of the reaction, 19.5 degrees Celsius. Here I have a lid with a hole in it, so the thermometer will go through the lid. I'm now going to add 2 spatulas of zinc powder to the acid in the cup. It will take a few minutes for the maximum temperature to be reached, so now I will wait. I'm now ready to do the next metal. Chemicals that we're using today are harmful, so please don't pour them down the sink. Your teacher will provide you with a container where you can dispose the residues for safe disposal later on. I can reuse this cup for the next metal by rinsing out the previous metal with water. What do I need to do to keep this a fair test so I can compare all the metal reactions? I'm going to use the same apparatus and the same quantities of metal and acid in each of the reactions. Don't forget to take the starting temperature at the beginning of each reaction.
Okay, so I want you to write the procedure now and write, copy the observations, complete the paper, and tell me which metal is most reactive as a conclusion, which metal is the least reactive as a conclusion. And put all the 4 metals in the reactivity order. Hurry, 5 minutes later. මෞලික proceed එක කියන්නේ. Yeah, proceed. මම දැක්කනේ අමුකද කරේ කියලා. ඒක දිය. දැක්ක දේ දිය.
Is it okay if you are in some parts?
That's okay. That's totally all right. What is important is that you train your brain now, right, to write something like this. So throughout the last few years, that your brain has been in a frozen state. වැඩ කරලා නැහැ ඒක. I'm trying to like break ice. If your camera is off, make sure that you complete the work and send me the answers. And anyway, I need the reason why the camera is off, you know that. Hey, Amaru. Mauli, read කරන්න බලන්න steps.
So first we should take the cup and put it in a beaker so it won't spill. Yes, spill. Then we have to put the thermometer inside the cup. Then measure it before the reaction happens.
So what is in the cup?
The acid.
Oh, acid එක දාලා තමයි measure it before කරන්න ඕනේ.
Yeah. Before
Okay.
the reaction happens.
Then before the reaction happen, you are measuring the temperature of
Yeah.
what?
Of the acid.
So you didn't say that you added the acid. Good. දැක්කනේ ලියන්න try කරොත් ලියන්න පුළුවන්. බැරි කමක් නැහැ. Right?
What is it called?
Polystyrene. Polystyrene cup කියනවා. Polystyrene cup. It's all depends on your effort. When you put the effort, you become able person of doing it. Okay? Read. Yeah.
Stake, the stake operation stands for more protection, including insulating cup into it, while putting the dilute acid into it first. Later close the insulating cup, but before add the thermometer and report the initial value to it. Then after adding to the acid balance, after some time, we see an increase in temperature. So when we use final speed minus initial speed, that value will be increasing from bottle stop according to the reactivity series. And,
Oh, wait. Now, when you write the procedure, you don't write all these judgments, right? Procedure එක ලියනකොට ඔයා ලියන්න ඕනේ. You just write what you do. For example, place the polystyrene cup inside a beaker. That's your first step. It's simple, right? And transfer 20 cm cube of dilute hydrochloric acid into the cup using a measuring cylinder. That's your second one. Right? Using a thermometer, measure the initial temperature. Right? Use insulating lid, right? add the metal, close the cup, and let the temperature rise. Observe the highest temperature. That's it. You're not going to say the reactivity series stuff, you're not going to say. It's just a procedure. Do you understand it? Right, good. Right, move on. Good, very good. Very good.
The order, right?
Yeah, so you wrote the conclusion, very good. Right, but you need to give the observation table. You have to find the temperature difference. And also you have to look at the observations and decide why magnesium is highest. Why magnesium is highest? Anyone in online, can you tell me why magnesium is highest in the reactivity? Why is it highest in the reactivity?
As change in temperature
Yes,
and rigorous observation.
Yeah, Jennifer?
It has a high.
I'm sorry, I can't hear you properly. So why magnesium is highest in the reactivity?
So it's a group 2 method.
No. I'm not asking why, explain why. I'm not asking explain why. I'm asking why do you decide it is the highest reactive in this case? As one evidence is vigorous fissing. The other evidence is temperature change. Look at the temperature change. It will give the largest temperature change. Yes, Januka, your answer is correct. So today is like mainly experiment day. And then after that, we'll be writing some important things about those reactions. I'll give you just 2 more minutes to conclude your meeting, and then we'll move into the next. All right. Okay, so then you find magnesium is the most reactive, copper is the least, iron, zinc, so on. Right? Okay. Now let's move into any clarification, any problem, online students. If not, please confirm whether you are okay or not with the experiment. Did you get the conclusion that magnesium is most reactive, copper is least reactive, and second most reactive is zinc, and third most reactive is iron. All right. Right. Now let's write the topic metal displacement reaction experiment. Write the topic metal displacement reaction experiment. Huh? Uh, if you have enough space in the tube, if not, write in the book and attach that paper to the tube. If you have time, if you have space, you can write, no problem. But this will take a little space, by the way, right? So metal displacement reaction experiment. So this is also done in order to find which metal is more reactive. Rather, I explain, I want you to listen to this video and do after that, I will be explaining that fully. Don't worry. Okay, metal displacement reaction experiment. Metal displacement reaction experiment. Okay.
You can put the metals into an order of reactivity based on the temperature rise, with the most reactive metal having the highest temperature rise, and then the least reactive metal having the lowest temperature rise. You need to know words and chemical symbol equations for these reactions. Now let's take a look at the products formed from these reactions. As all of the metals react with hydrochloric acid, one of the products formed is a chloride salt. The other is a gas. Let's test to see what that gas is.
There's a gas producing the reaction also. So they have collected the
If I
gas.
insert a lid split into this test tube full of the gas, let's see what happens. There was a squeaky pop, so the gas must be hydrogen. Now let's look at the word and balance symbol equations for these reactions. Can you write the balance symbol equations for magnesium, iron, and zinc with hydrochloric acid to make the chloride salt and hydrogen?
You know those reactions.
We didn't write an equation for the reaction of copper with hydrochloric acid because there was no reaction. Check out the additional resources in this video to explore the reactions of metals and acids further. So, we have now looked at the reaction of metals with water and acid. As long as the metal reacts,
Now, we have done experiments and we discussed reaction of metals with water and acids. From that, we found the order of some of the metals reactivity. So this is the second day we are doing reactivity series, right? This is second one, right? But there are some metals that you can't find the reactivity of them. Right? In order to find the reactivity of those metals compared to the other metals, we are using this metal displacement reaction. Right? Okay. Why are we doing this? Specific objective why are we doing this method? What you guys are listening, huh? No. Why are we doing this experiment, Ananya? Look at here. Now, I told you very clearly 3 statements here. Those 3 statements just have bounce off from your head. I said we did experiments to find out the reactivity with water and metal and acids and metals. We found some of them, the reactivity, lithium, sodium, potassium, we found. It became potassium, sodium, lithium. Right? We found calcium and magnesium after that. Right? And we found acids and metals now. Right? Magnesium, zinc, iron, copper. But still there are metals that the reactivity position hasn't been decided. Because they don't react with HCl. Now copper doesn't react with HCl. So you need to know where are they in the reactivity series. I know we have by heart the reactivity series, but how do we place them in the reactivity series? That's why we are going for our third experiment. Do you understand? There are metals whose reactivity hasn't been experimented. So we won't find out where do they stand in the reactivity. You get it? All right?
split into the test tube full of the gas. Let's see what happens. There was a squeaky pop, so the gas must be hydrogen. Now let's look at the word and balance symbol equations for these reactions. Can you write the balance symbol equations for magnesium, iron, and zinc with hydrochloric acid to make the chloride salt and hydrogen? We didn't write an equation for the reaction of copper with hydrochloric acid because there was no reaction. Check out the additional resources in this video to explore the reactions of metals and acids further. So, we have now looked at the reaction of metals with water and acid. As long as the metal reacts, we can use observations about how quick, vigorous, or hot the reaction is to compare the reactivity of different metals.
As far as the metal react with water and HCl, we could use the observations to place them in the reactivity series. What happens if they don't? You need some other way of comparing them. That's what you do. You get it? Okay. So here we have a kind of a table observation table, right? So you will be mixing metal with 3 solutions of metals. I don't know how the table is given in the video, but if what you do basically, let's say you have metals, I'm just example, magnesium, zinc, and copper. You are going to add magnesium into zinc nitrate. I don't know the compounds. I don't know. I'm just writing the normal, right? And you have copper nitrate and magnesium nitrate as well, right? So if you put zinc into magnesium, this box, right? You put piece of zinc metal into magnesium nitrate solution and see whether there is a color change. If there is a color change, that means your zinc is going to displace magnesium from the solution. If there is no color change, that means zinc is unable to displace magnesium from its solution. Right? Again, then up to zinc down in a copper nitrate. Right? If zinc is more reactive, it will make copper to become an element and zinc to become a compound. The reactivity series is the one at the top prefers to become a compound. One at the bottom prefers to stay as a metal. You get it? Right? So if a reaction happens, you will see a color change. If you see a color change, that means there is a reaction happening. If you see a reaction happening, that means there is a displacement reaction. In order to do the displacement reaction, the metal which is displacing the other should be more reactive. More reactive. මේ experiment එකේ observation එකක් තිබ්බොත්, if you see an observation, that means the metal added to the salt is more reactive than the metal produced in the reaction. Zinc is more reactive than copper. So this is less reactive. Since we know the reactivity series, we can tell it, but we want to experiment and see. Do you get it? Okay, so that's what they are going to do. So have a look at this carefully.
However, if the metal does not react with water or acid, it can be very difficult to compare the reactivity. In this experiment, I'm going to add a strip of metal to a solution of a compound of another metal. The more reactive metal will displace the less reactive metal from its compound. So you will always have a reaction to compare the reactivity of the two metals. I'm going to do these reactions on a microscale level, as these chemicals are harmful to the environment and need to be disposed of correctly. In this reaction, I'm going to use this spotting cone. I've added labels to this piece of paper so it is easier to know where I'm putting each solution and each metal. Using a dropping pipette, I will add a small amount of each solution to 2 of the depressions. Before I start, I must put eye protection on. I'm going to add magnesium sulfate to the first row.
Do you want to have the table drawn? Right? So don't draw the diagram. Have the and you are going to write the observation in the middle of your table cells. Sorry? No reaction. So there is no point of putting that. That's why she didn't put solution over there. We are expecting the power cut at 7:20. So we need to go like 20 minutes, 40 minutes with backup plan, backup power. But Most probably, I might not have that much of backup, but we'll try maximum. Okay, sorry, there was a connection issue. Now we are back on air. Please put your videos on. Okay, let's watch the video.
Now I'm going to add zinc sulfate to the second room. The sulfate solution to the third room. Now I'm going to add small pieces of the metal to each of the rows, starting with magnesium.
And observations.
Next, I will add zinc. And finally, copper.
Here it was. I moved the row. Lamai vinagre kinda, please. There you go. Mana benim pasang? So we are getting electricity breakdowns at wrong times now. Right? So then, in the sense, right? Okay, let's move on.
Next, I think. Finally, copper. I did not need to add magnesium to magnesium sulfate, zinc to zinc sulfate, or copper to copper sulfate. Why? A metal does not displace itself. Over the next few minutes, we need to observe which reaction mixtures have reacted and which have not. Write down your observations in a results table. These are the results after leaving it for 5 minutes.
This is very important. So you have your table. Tell me in which cells the reaction has happened. Magnesium and zinc sulfate, there is a reaction taken place. Magnesium and copper sulfate reaction has taken place. So look down, wait, look down. Magnesium, zinc sulfate, yes. Magnesium, copper sulfate, yes. What else? Yes, online students. Where else the reaction has happened?
So zinc and copper sulfate.
Very good. Zinc and copper sulfate reaction has happened. Right? Okay. Now what I'm going to do, so I'm going to take this one into our board, right? And then we'll explain you how to make the conclusions and how to write the reactions depending on observations. That's the plan, all right? Okay. Okay, so this is the observation you had, right? Okay, so then you can see this one, there is a reaction. So what is that situation? You have added magnesium into zinc sulfate, right? This is also, there is a reaction, right? You have added magnesium into what? Copper sulfate, right? You have a reaction where zinc is added to copper sulfate also, right? මොකද මේ නිතිල මොකද ප්‍රශ්නයක් නැහැ කවන්නේ හරි. So what is the possible reaction you can get? Magnesium and zinc sulfate, what's the possible reaction? Yeah, Nitila? Displace. Magnesium sulfate is produced. Right? So the zinc tamai mein podi. You can see like black color solid products. Yeah.
Copper and zinc sulfate. So reacted.
Cool. Next.
It's blackish.
No, there is no apparent. Now all these three have not reacted.
So is it?
That's what we are going to learn, right? So if magnesium reacts like this, it means magnesium is more reactive than what? Zinc. Only the more reactive metal can displace the less reactive element. right? So magnesium reacts with copper sulfate means you get copper and magnesium sulfate. Not only the color of the metal, even the blue color has faded, right? Because copper sulfate is blue in color. Magnesium sulfate is colorless, right? Copper sulfate is blue because it's a transition element, right? And zincs and copper sulfate, even you can see the color has reduced and a lot of zinc is produced. Can you see? Right? So then this is zinc plus, sorry, copper plus zinc sulfate will be the product. Copper plus zinc sulfate. So in all these cases, you derive the one in the reactant metal is more reactive than the product metal, right? Thereby, you can say magnesium is more reactive, zinc is less, and copper is the least. So you can't expect zinc to react with magnesium sulfate to do a displacement reaction. Why? Zinc is less reactive than magnesium. Okay? Zinc is less. Group එකේ පල්ලෙහා නම් එයාට බෑරව displace කරන්න. To displace, you must be superior in the reactivity. That's the idea of this experiment. Okay, we are going to observations and then conclusions, reactions. Table එකේ observations ලියා ගන්න. මොනවද observations? A new metal is produced, right? Copper sulfate, the color has faded, right? If there is no change, then you write no reaction. Yeah.
No reaction, zinc and magnesium sulfate. Product of we get the same one.
I mean, there is no reaction. Because zinc can't react with magnesium sulfate because zinc is less reactive than magnesium. Yeah. Under conclusions, you need to write the equations. You must be able to write the equations of equations at any time once you learn this. So the conclusion is magnesium is most reactive and copper is the least reactive and zinc is in between. But they are not very hard things. We already know it. But this is how we do them in experimentally. Is that clear? And all these things that you just did are not for you to buy heart. All of them are for you to get the skill of comparing the reactivity. Okay. By heart කරන්න ඕනේ by heart කෙරුවෝ first day. Right? ඒක ඔයගොල්ලෝ දැනගන්න ඕනේ ඒක try කරන්න ආපහු. That's the reactivity series. Okay. Right. So here we go. Some important, more important facts about these reactions. But first of all, we will finish watching the video, right? Otherwise, it's like halfway done now.
You can see that we've only had a reaction in 3 of the experiments. You can see bubbles forming and a darker metal. Magnesium has reacted with zinc sulfate and copper sulfate, and zinc has reacted with copper sulfate. We can fill in our results chart with a tick or a cross to indicate if there's been a reaction. Where a reaction has occurred, the metal is more reactive than the metal in the compound. The more reactive metal has pushed or displaced the less reactive metal from its metal compound. Therefore, we can put magnesium, zinc, and copper into an order of reactivity. Magnesium has reacted with zinc and copper, therefore it's more reactive than both metals. Zinc does not react with magnesium sulfate, so it does not displace the metal. This means that zinc is less reactive than indicate.
So this table is quite useful straight away to find out which one is most reactive. Look, magnesium is displacing both zinc and copper. That's why 2 ticks. So you decide that has the most reactive one. And copper doesn't displace anything. Then it is the least reactive one. Zinc cannot displace magnesium, that means less reactive than magnesium. But it can displace copper. Therefore, it is more reactive than copper. You get it? So this ticks and right, ticks and process here will help you quickly figure out which is more reactive. So why are we doing this? Because in the exam, you will be given like many different examples, not the normal ones you know. So then you have to carefully figure it out what's the answer is. Okay, so with that, we have come to the end of the experiment session, right? So what I'm going to do now, we will go a little deeper in the theories. We will go a little deeper in the theories. Okay, right, little deeper in the theories. Right, so normally when the theories are there, okay, my goodness, what is this, right? But can't help. Let me take a few reactions now we just learned. Sodium reacting with water, giving you sodium hydroxide and hydrogen gas, right? Okay, so is this reaction we learned under metals and water, right? Is this redox reaction or not? Is this redox reaction or not? How can we quickly figure out? I have given some hints as well. This is a redox reaction. How do you say that? Electrons. Oh, okay. Sodium is getting oxygen. Okay, not bad. Right? What else? Why don't you work with oxidation numbers? That's what you have been doing. Sodium oxidation number is 0. Right? And what is oxidation number of sodium here? +1. Right? Yeah, so what's the problem?
So sorry, so mistake.
Okay, right. +1. So then what happens to the sodium? Sodium, what has happened to the sodium?
So it gets oxidized.
It gets oxidized. Very good. It has got oxidized. Oxidation number. So this is oxidation. So can you see all these reactions? Now here, displacing hydrogen. In order to displace hydrogen, the sodium has to be where in the reactivity series? Above hydrogen in the reactivity series. Is it? Yes, it's way above. Right? Meanwhile, who is getting reduced? Right? Hydrogen is +1 here. Hydrogen is 0. So this is a reduction. So basically always the more reactive metal is going to get oxidized. That's what you need to understand. So these are redox reactions. Right? Okay. So this is the example number 1. Example number 2. Let me take magnesium and HCl into account. What are the products? Magnesium chloride and hydrogen gas. So then here I'm going to go for like even ionic equations, right? Magnesium chloride is also aqueous, hydrogen is gas. Is that clear? Yeah, we need to put what? 2 in front of HCl. Make a redox there. Is this redox or not? It is not redox. Why?
Getting oxidized or it is getting oxidized.
Nothing is getting oxidized or not. What about you, Vetuki? It is redox or not? Huh? Not. Ananya? Okay. You can't tell. Oh, it's not redox. It's not redox. Mithila? Okay. What about online students? Is it a redox reaction or not?
Sorry, docs.
It's a redox reaction. Dulmi කියනවා redox කියලා. This Dulmi කියනවා එක redox කියලා. Why you call it redox reaction, Dulmi?
The change in oxidation.
Change in oxidation number. Magnesium के මොකක්ද oxidation number එක? ඔව් කතා කරන්නේ element form එකේ න 0. Metal ion form එකේ it's going to be what? +2. Right? Therefore, it is an what? Oxidation. It is an oxidation. What about hydrogen? +1 to 0. This is a reduction. Hydrogen displacement is also what? Hydrogen displacement is also what? Redox reaction. It's a redox reaction. And in order to do that, again, the metal has to be where? Above hydrogen. Because here magnesium is more reactive than hydrogen. It's a displacement reaction. Metal must be above hydrogen. Right? That's why the metals below hydrogen can't produce hydrogen with HCl. Copper didn't react with HCl today in the experiment. Why? Copper is below hydrogen in the reactivity series. All right. Okay. Quickly copy this. So you can write a small heading saying displacement reactions are redox reactions. Right? Displacement reactions are redox reactions. Let me share a screenshot of this. Displacement reactions are redox reactions. Displacement reactions are redox reactions. I'll be showing you the ionic equation also, what really happens here, magnesium reacts with H plus. Your chloride ions are getting cancelled because it doesn't change the oxidation number. Here is the ionic equation for this reaction, right? Have a look at this more. If I further write, in this case, magnesium has given out electrons. How do we know that? Because we just realize it's an oxidation. Oxidation number, loss of electrons, right? So this is called ionic equation. Ionic equation. Now I am writing half ionic equation. Half ionic equation. When I write half ionic equation, I have to show the electrons. Now who's going to get electrons now? Hydrogen ions. So two hydrogen ions will get electrons and become hydrogen gas. That's what really happens in this process. Okay, so now you can copy that quickly. Online students, they are in another 4 minutes time. Again, I might get disconnected because of the electricity transition, right? Stay with the meeting. Huh? Meanwhile, you can copy this. Sorry. Because 2 HCl. You have 2 HCl here. Cl ions are spectrate ions. I will teach you how to derive the ionic equation later on. Okay. Now these days you guys are not like very matured enough with the equations to understand. Just go ahead with what I have written here. Right? I will definitely help you for the ionic equation after we are done with the electrolysis as well. When you write, think about the valencies. Magnesium valence is 2. Therefore, you have to write MgCl2. Magnesium valency 2 in the tamai chlorine val 2N. Right? Okay. So meanwhile, you try these examples. Just apply this zinc and sulfuric reaction. Zinc sulfate aqueous and hydrogen gas. I want you to write the ionic equation. Guess the ionic equation. Quickly write down this question. Otherwise, in few minutes time, the current electricity is going to be on. Hurry up. quickly write down that question reaction. You need to write the ionic equation for that and see what is going to oxidize, what's going to reduce as well, right? Right? Okay, continue online students just for few minutes. I'll be offline here in the board. Try to do that for everything. Zinc, the zinc ions charge is 2 plus. Zinc sulfate and hydrogen ions. Sorry, ionic equations.
Answer part one.
Liver Right, Lamai? Okay, so things back to normal. Put your videos again. Then we will learn ionic equations. You haven't tried. So here the magnesium, H plus, ignoring chloride ion, magnesium 2 plus, hydrogen gas. If you have the end by zinc, you need to write that.
Why we chloride?
Why didn't we take chloride? That because it hasn't taken part in the redox chloride is minus in both cases. We call them spectate ions. Right? We'll be learning that in detail, don't worry. Become oxidation කියලා ලියන්නත් බෑ. ඇයි කියලා ලියන්නත් ඕනේ whether the oxidation number changes or not. All right, ළමයි, let's see. How did you write the reaction for this? And then how did you figure out the ionic equation? First of all, right here, zinc oxidation state is 0 and zinc 2 plus oxidation state is +2. Right? Thereby, this is oxidation. This is why you call it oxidation. Right? And this is +1 and this is 0. So you call this what? Reduction. Right? So then you have to carefully take the iron out. Now here it's zinc metal. What you have in sulfuric acid? What are the ions you have in acid? Make formula එක දිහා බලලා කියන්න. What kind of ions you have in sulfuric acid? Sulfur. Online students, what do you have in acid? You have a polyatomic anion. What is this polyatomic anion? Sulfate. Right? Sulfate ion. And then you have simple ion. What is that simple ion? H plus ion. Right? But sulfate ion doesn't have any reaction in this case. So then zinc and 2H plus ions are reacting. Right? Sulfuric, you have sulfate ion and 2H plus. And then right? Zinc sulfate, now zinc is no longer 0. What is zinc charge? It is zinc 2 plus. And then you get what? Hydrogen gas. So this is what you call the ionic equation for this reaction. Sulfate ions in both cases, you can see that. So then it will get cancelled out. It doesn't have any change. Right? You take only the ones which has undergone change. Zinc solid, aqueous, zinc aqueous, and hydrogen gas. You get some idea? Right? All right. Okay, shall we try? So that was the example number 3. Example number 4 is a displacement reaction. I'm pretty sure you can do it by comparing the previous one. Here we have zinc sulfate, copper. Right? Okay, online students, you can send me the answer in WhatsApp. Try the question number 4. Let me try that. Perfect, right? Because they are same object. The AFC of a negative iron negative. Iron. See you. 2 plus. So here zinc is iron, but copper is. Million now, for oxidation reduction phenomenon. If you can send the answer in the empty chat, that's much better. Okay, Asad said copper reduction, zinc oxidation, very good. You are correct. So this is a normal metal displacement reaction. අපි අර කරේ metal එක දාලා කල එක වෙනස් වෙච්ච එක. So we are writing the equation for this. You just write this by looking at the previous reaction, Ananya. Zinc sulfuric වගේම zinc copper sulfate. There is no big difference. No. We are prepared. Yeah.
Yeah, it was the discussion of C, 2 plus.
We don't see who does.
The report
Which one you know?
answer
That eleven zero plus one. It's possible. Okay, writing may පිළිවෙලක් එකයි මාට මේ පැටලෙන්නේ. Right, shall we check the answers now? This is very simple one and most of you have given me the correct answer, right? So here zinc is 0, here zinc is 2 plus. So very simple again, what is this? This is oxidation, right? Online students, you can hear me, right? Even though you can't see me properly.
Yes, yes.
Okay, so you have copper 2 plus and we have copper. So this is what? This is reduction. This is reduction. Okay. Too bright. Alright, then if I make it what do you call darker, what will happen? Not enough light here. Well, I will reduce it in next term. That's for time being because why your eye is hurting because it's dark around, right? Just give it, right? Let the eye to settle down for a few minutes. It will be all right, right? So here we have zinc In the reactant side, it's just solid, it's a metal. I mean, no need to find the electron equation by the way. And copper is in the 2+ form because in an aqueous form, right? And in the product side, you have what? Zinc 2+, and this will be what? Copper solid, right? Actually, it was only the white letters, right? But with the dark letters, I think you can manage that, right? So this is your ionic equation. So copper has got oxide reduce and zinc has got oxidate. Okay, so what are we going to do next? And we are going to do a practice question, right? So let me reshare the practice question for the students online, and then let me show you the question as well. Okay, so you need little more time to write this down. Are you done writing? Done writing? Okay, right. So here is the practice question. Okay, now you can start answering. Don't worry, I'll make it bigger so that you can read it properly. It's kind of a long question, so start answering now. Second part of the question is in the other image. All right, start.
That word after power.
Use your pen to write the answers, otherwise you can see this. No need to write question. This is to practice whether what you just learned is okay. So the people who said that you have electricity cut, but and then you didn't put your videos on, you guys still have the electricity cut. Shakya, German, Januka, you never appeared today in the class.
Yes.
I didn't hear anything what you said. You are not audible. Like communicating to an alien ship. I kindly request the students who are joining online to have this camera problem fixed, right? By next week, at least have a small web camera or something like fix. Otherwise, your interaction to the class is not assured. So what will happen then? Parents, after everything happen, then it's a problem. Even though you can't write some of the reactions, you still can do this. You can answer some of the questions, right? You can think about oil rig, who's getting auxiliaries, who's getting reduced, and you can write those reactions. You can definitely answer part F. You can try part G for sure. Ionic equations are the ones that you find difficult, right? But even ionic equation you can try. When magnesium atom become magnesium ion, whether the electrons are lost or not. That's a simple thing, no? Right? Magnesium is in group 2, it has only 2 electrons in the last shell. You can think about it, right? And then they ask, why does the displacement reaction occur? That's what we have been learning about the reactivity series.
Reactive.
I'm sorry.
In the F part,
Yeah.
so we just put like tick to the ones that are reactive.
Or you can write the product C1, right? Then the main reactor, and sulfate and copper. Displacement, right? But you need to use your reactivity series in order to decide. What's the point? More reactive, Nitila? More reactive metal will displace the less reactive metal. This is like summary of what we like did throughout the last part of the today's class. Some of them might be difficult, that's normal. Ag and cellulose valence is 1. Insects. They are going to write on the board. It's a touch screen, so then they actually land on it.
Lead in the reactivity series.
Hmm?
Lead.
What do you mean? Lead, yeah. Okay, let me give you where is lead. Lead is just above hydrogen. Just above hydrogen. I didn't give you in the reactivity series, now I'm giving it. But don't try to buy hard, right? Just above it. You're done with answering, online students? How about you, Dhulmika? There's a small problem that I can't take the WhatsApp answers on the board, but still you send me the answers in WhatsApp. I can go through your answers now. They will take care of themselves. They dragged the question now.
That's why.
You not insects. ඔගලන්ගේ යාළුවෝද කොයිද?
Yes.
Best friend.
To take the question away from you. You can say, no, we are not the ones there.
Good friends.
They are the true friends.
Yes, sir.
Okay. Or with another true friends. Or another true friends. Okay, did I erase? No one has.
So what's Silver's ID?
I need number.
What's a silver?
Valency. One. All right, so let's check the answers now. You are in part G. Abbalum answers. Okay, we will check the answers. Otherwise, not enough time to finish this. Right word equation. Now, normally in your Cambridge papers, very hardly they ask you to write word equation, but there can be situation they can ask. So let me write this for you. Right? According to this, you are reacting magnesium. Right? Then balagan hariyata liyagan berinana then focus karaganda. Magnesium and copper 2 plus. අනිත් journalist ලා වගේ ලියාගෙන යන්න එපා. ඉස්සෙල්ලා බලාගන්න මොකද වෙන්නේ කියලා. Right? They close it, means they close it.
These are true friends.
So your friends.
Yes.
Don't worry, lamai, may insects are like bothering. No. Wait. Okay. Right, so copper to sulfate, right? And when the displacement reaction occurs, then it's going to be what? Right? Magnesium. See? Bring on it. These are very notorious. Right. And magnesium sulfate and copper. Right? So that's the reaction. And next, why does the displacement reaction occur? Why does it happen? Why does this reaction happen? Why magnesium can displace copper? Yes, then you say magnesium is more reactive than copper. More reactive than copper. Also, you can say magnesium is higher. Higher than copper. Next, write the equation for what happens to the magnesium atom. Now I know magnesium atom has to get oxidized. Use your common sense. It has to become the iron. It has to become the iron. So you get the
What's the exciting?
No, we don't kill our friends.
no idea.
Don't kill our friends, they're trying to help us.
They are not friends. They are making you to stay another half an hour in the class.
Are you?
So how come they are friends? Right. That means then kill them. No? So then magnesium becomes magnesium 2 plus and electrons are given, right? Which type of reaction is this? Electrons given out means what's the reaction? Oxidation or reduction? This is oxidation, right? So then this reaction is oxidation. Okay. And then part D, right? Write half the equation to show what happens to copper ions. You started with copper ions. If magnesium is undergoing oxidation, copper ions have to undergo ions. Copper ions have to undergo what? Reduction. Okay, and it will give you what? Copper. Right? Okay, and it's a reduction, right? So this is what you need to write, reduction, right? Okay, which metal shows greater tendency to form positive ions? Like how the magnesium has become positive ion, copper 2 plus has become atom again. So which one has a greater tendency? Magnesium, right? Magnesium has greater tendency, right? Tendency to become positive ions. लिया गया answer सारे to become positive ions. Positive ions, right? Okay, so we'll go for the second part next week. Okay, you need the previous page to write the answers. Hari sekolah kali mehin muka tinggi.
So they must be taking the day.
They are very not just go
Small.
taking a smart board there. Done, right? Hurry.
Yes,
Insects are much better than you. They are more efficient.
Yeah.
All right, so let's go to the next one. We were in question number E, right? Write the ionic equation for the displacement, the whole displacement. So you put magnesium into copper ions, and that gives you magnesium ions and copper. You can even put the physical state because you put magnesium solid copper 2 plus, and then the magnesium becomes the aqueous solution and copper becomes the solid. Is that clear? Right? So don't think too much about them, right? It's about the reactivity and then reduction, oxidation, ability to identify that. That's the most important thing, right? Okay, right? Don't think too much about it, don't like stop thinking 100%, right? Okay, okay. Which type of reaction is it? What's this reaction now? This is a redox reaction. Why? You just prove, right? You just prove one part is oxidation, the other part is reduction, right? So this is redox reaction. Okay, use the reactivity series whether to see these reactions happening or not. Iron, copper. Tell me, is iron is more reactive or copper is more reactive? Iron. So iron is more reactive in the sense when the reaction one can take place, right? So use the react design. Yes, first one it react, right? They react because iron is more reactive. Then they are talking about silver and calcium. Who is more reactive?
Calcium.
Calcium is more reactive. So then silver can't displace calcium from calcium nitrate. So then no reaction. Methuki there no other? No reaction. Because silver is less reactive. Next, zinc and lead nitrate. As I told you, lead is just above hydrogen. Right? Therefore, definitely zinc is what? More reactive than lead. If that's so, will that reaction take place? Yes, because zinc can displace lead from lead nitrate. So then the reaction happens because silver is more reactive. Please follow the inequality. Describe what you would see from each reaction, right? Enough reaction in iron plus copper nitrate. What's the copper nitrate solutions color? Copper color. What's the color of copper solutions? Copper solutions? Blue, right? So then this is blue solution, and it will become what? Iron nitrate and produce copper. What's the color of copper metal? What's the color of copper metal? Brown or pink, right? So the blue solution turns into actually iron nitrate is a green solution. So this is from your qualitative analysis notes, right? And copper is pink solid. So they are asking us to give like color changes. So this reaction, this is the reaction, and this is the color change. Blue solution turns greenish, and you get pink solid rays. And this no reaction, so no observation. I mean, no change in observation. What about zinc and lead sulfate? Actually talking, zinc is silver, lead is silver. So it's little difficult to what? Identify color change. If there is a transition metal, yes, it's easy. But if it is not, then little difficult. Right? So then here, difficult to guess the color change. Difficult to see the color change. See a color change. Only thing you can see is the existing metal dissolve. The zinc will dissolve. You can say zinc solid dissolve. Zinc solid dissolve. That's the only observation you can see. Okay, so this is about your what reactivity series. මේක කරලා ඉවර වෙනකොට ඕගලන්ට idea එකක් නැත්නම් reactivity series එක ගැන ඒ කියන්නේ you have to revise, revisit and question your knowledge on this. Understood, right? Okay. So now we are done with reactivity series. Next, we have to do metal extraction and electrolysis. Right? Metal extraction, we will be finishing next week itself. That's the iron extraction. After that, we'll be starting electrolysis. Okay. So with that, I'm going to end the class for the online students also. Right? And please do answer. There are like two messages. Listen, reactivity series online assignment must be done. All right. Next, tomorrow the revision class will happen as usual. Okay. Most of you haven't submitted the essay paper assignment. Right? Most of you haven't submitted. Please attend the class with the answers. Don't come to the class without the essay paper answers because I'm discussing. Understood? Okay, so now you can peacefully go home and I'll see you guys next week as well. Good night. Bye.
Thank you, sir. Bye.